So our talk is Security as a Service, work where your engineers live. As she mentioned, my name is Taylor Lobb, Manager of Security and Privacy Architecture for Adobe. I'm responsible for security testing, vulnerability detection, threat modeling, that kind of thing for our digital experience business unit. I've been at Adobe for a little over 5 years now. I said digital experience business unit. You might be wondering what that is relative to Adobe. Julia's actually going to speak to that in a second, and with that, I'll kind of give it over to her.
Gracias. So my name is Julia Connect, same title. I'm in charge of the secure product lifecycle at Adobe Digital Experience. So to give you guys a little bit of context about what that is, Adobe is a decently sized business down the street. And as you can see, we've kind of grown over the years since we were a startup in John and Chuck's garage, I believe. So over the past several years, we've made a lot of acquisitions. So I circled the red ones, or I guess the ones that are circled in red are the ones that are part of the Digital Experience Business Unit. This slide is kind of old. And so since then, we've kind of acquired several more companies. And so I think that line continues to kind of go up and to the right. So just to give you an idea of all kind of the different companies that we're working with in kind of acquisitions and that kind of thing. So I wanted to start out with an analogy that I'm going to try and pull through the whole entire presentation. So we work really closely with our software engineers. And so I have a picture here of a volcano. So delivering software the way that our engineers do it is kind of like how Frodo was asked to bring the ring to Mordor, right? So the dev team takes the software to the internet, which is a dangerous place full of all kinds of a bunch of really scary things like hackers and APTs and ring wraiths and all that kind of stuff. And so I wanted to dive into how do we work with these people? How do we work where they live and help them to accomplish their goal of delivering software? Okay. So discovery. So the first thing that we did when we were looking at kind of tweaking our secure product lifecycle was talking to a lot of different people. We spoke with our engineers, program management team, engineering managers, and other people to talk about the logistics of how we deliver software. How does it go through different levels of testing? Who approves it? Who comes up with the ideas? How do they get designed and pushed out? So, and what kind of practices were currently in place when it came to security? And I got all kinds of different answers. Most of them were like, isn't that your job to do security on these things? So there were a few things that I wanted to kind of share that were key takeaways that helped us kind of architect our approach to working with our engineering problems. So the thing that I found very consistently was that security has a PR problem. So our engineers are building really cool stuff like this roller coaster. So customers want to come use the software that we're building. They want to pay us money for these things. There's all these cool flashy features. It goes fast. There's a lot of analogies in my talk here. And so our engineers are building really exciting stuff, and they're excited to build it. So I found, however, that when we're talking about security requirements, our engineers and kind of some of these teams described it as like a tax on the work they were doing, or something that slows them down, or something that they don't necessarily want to engage in. And so I actually had someone put it really, really illustrative for me. They said, I don't quite understand what all of you guys are trying to do with security, but it sounds like if I took what we're building and disconnected it from the internet and encased it in concrete and dropped it to the bottom of the ocean, I might be in the ballpark of like what you guys are trying to get at. So I don't know, do you guys get this like kind of like PR problem that I'm talking about? Like people just assume that we're kind of coming in and saying no to everything. And so that's obviously something we have to solve, because if we are not, or if we're perceived this way, then we're not getting invited to the parties and the design reviews and all of these kind of things. And then the other thing that I found is that we have kind of a process problem. So we've got our engineers over here they're all happily building software. This is what they were hired to do. This is what they're excited about. And then they have, on top of engineering, I think you've probably heard this, right? Like, security is everybody's job, and compliance is everybody's job, and process is everybody, right? Like, all of these things are everybody's job, but their job is to build software, right? Like, this is their actual job description. And so we have different people kind of coming in with a bunch of different requirements. So we've got compliance. They come in with, we have to meet these controls and be SOC 2 compliant and reach FedRAMP and all of these different things. Then we have operations who comes in and they say, well, you have to do it like this, and here's our new process, and this is what we're putting in place. And then you have security who comes in and says, well, on top of that, think like a hacker, and here's all your security findings, and you need to fix this, and you need to, stop building. And so our engineers start to get like a little bit confused and frustrated, and at some point, they're like, okay, how can I make sense of all of these things, right? So with all of that in mind, kind of designing the SPLC ideology, we kind of realized that our engagement with engineering teams had to change. It needed to be an approach that was more of a partnership instead of someone coming in and saying no all of the time. It needs to be something where we're involved at kind of all of the steps and we're in lockstep with them. So back to this, because I spent a lot of time building this slide. The internet in this analogy is Mordor, and as we know, one does not simply walk into Mordor. So where's the security team in this, right? We're currently not present, so are we the eagles who fly in at the end and we save everything and say, okay, we should have probably been here the whole time? We get to, when we build secure software, we get to be the fellowship of the ring. So we come in and say, and you have my sword, and you have my axe, and all of these different things, but it's really and we'll do threat models, and we'll do pen tests, and we have this service catalog of things that we offer to the development team that they can request from us, and then we will return these things to them and help them to achieve their goal of delivering the software. So once again, our job is not to deliver it, it's to assist and help the engineering teams and not stand in the way. So one of the strong ways that we partner here is to leverage the existing process. So this was our service lifecycle. This is how we build and deliver software in the digital experience business unit. It is got a lot of different steps here. And does anybody see security on this slide? Right, so it's down there. And it's in line with these other 4 words that are not the same part of speech. And what do they even mean? And where do these kind of get involved, right? I think the message is this stuff should be throughout, but there were not actual logistical checkpoints for what is this. It was just kind of a security is everybody's job kind of thing. And so we went ahead and worked with our program management team to kind of put these things into place. So when they reach certain points in their development life cycle, here is the activity or the service that you requested the security team. Here's how you engage us, and here are the triggers that make sure that our team is engaged at that point. So yeah, no longer a single checkpoint actually does mean something, and our program managers are aware of what that is. Another way that we partner is to leverage the existing tools. So all of our security requirements go into Jira. We don't send out emails with PDF attachments without also putting the issues into Jira so the teams can pull them into their sprints and get those things prioritized and fixed. We don't say, go look at this tool over here and try and interpret the output of that thing. Everything's put into Jira with clear exit criteria and requirements around what the team needs to do. And then we also use Jira as our source of truth for reporting on that. And that reporting is automated and sent out frequently. So we're working from the same data set as our engineers. We're not spinning off different projects and ways of tracking security work. We're getting into their process. And then kind of our final partnering, not final, but the other one I want to call out is security champions. So security champions are our main point of contact on the team. We've got one on each of our engineering teams, and we put together, when we started rolling out the SPLC, a description of what a security champion is. So a security champion is an engineer on the team or an engineering manager on the team who's well connected throughout the organization, and they can help point us in the right place. They have a good understanding of the technology that they're supporting and the different components and the breakdown, and so that they can be involved in helping us to kind of identify where a problem's coming from, or if we need to do root cause analysis or this kind of thing. The security champion is there to help us with that, and that helps extend the security team's reach into the engineering teams and gives the engineering teams kind of their point of contact for who should they reach out to about security questions or that kind of thing. I guess next I want to talk about KPIs and measurement. So when we put together our KPIs for how we were going to measure the SPLC, we wanted to make sure that they were a few things, and one of those things is simple. So again, as much as we try and say it, security is not everybody's primary job description. We have to understand and make sure that that's clear to us. We can certainly expect good behavior from people and tell them how we want them to engage, but everybody is not a security engineer. And so they need to be simple and understandable and not leverage a bunch of security jargon and these kind of things. They should be clear. So you probably have about 3 seconds of someone's attention span if you're talking about something that's not integral to their everyday job. So I think that our KPIs can be boiled down to like a single sentence. It shouldn't be like something along the lines of like, you have so many days to get back to us on this, and then we have an SLA on our side and you have an SLA on your side, right? It's you're green if you fix your bugs within X number of days, right? It's really should not be more complicated than that. Consistent, so if you report every week, don't skip weeks. Make sure your clear, simple message doesn't change. And things take time. So what's important is to note, I think, that people pay attention to the things that are important to them. And so if things come up as important, like they're read on a report, we need to make sure that that means the same thing kind of across the board. It shouldn't be you're read for this reason and you're read and doing so much better, but we want to pick on you, right? So also unsurprising. So you should make sure that your dashboards are available. So anyone should know their status at any given time. They should be able to go look it up on a public internal space and say, okay, I'm red, yellow, or green for this reason. They should be able to go find out exactly what's causing that thing. So if we go and escalate on an engineering team, that should not be something where they're like, well, this is out of the blue. I had no idea that I had this problem. It should be something that's you're kind of partnering with the engineering team to report on. And then finally, they should be automated. This helps with consistency, and it helps to make sure that the efforts can be scaled. And so we automate our reporting based on Jira, so that when reports are sent out, they can go kind of click in and find exactly what the issue is and what is the action they need to take to be able to be back to green. So this is kind of, I guess, a quick overview of how we run SPLC. We now are going to have Taylor talk about one of our programs that runs in the SPLC, and so kind of putting this into practice.
All right. Clearly didn't get any laughs or a round of applause, so this was a bust. And clearly nobody has a sense of humor, so this next 15 minutes is going to be pretty rough. So anyway, as the transition slide said, I'm here to speak about one specific case study that we've put into place at Adobe, our third-party library discovery case study. And as I mentioned before, I'm responsible for security testing our products, finding the vulnerabilities. Third-party libraries, as we know, could represent a pretty significant risk or source of vulnerabilities. So how do we handle that, right? Before I get into that, though, I want to first talk about our automation system and methodology. But before I do that, I want to take you back to the beginning, when I first started at Adobe. So back when I first started, there was this world before automation and security testing, right? So we had these requirements of the engineering teams, and I'm going to use like code scanning or static analysis as an example, right? Engineering teams, security team comes and says, you're responsible for static analysis or code scanning of your code. Here's a tool. Have fun. Go do it, right? And basically, the engineering teams would then be responsible for learning that tool, learning how to get their code there, deciphering the reports, dealing with all that, and it may or may not get done, right? So as a result, maybe the utilization might be kind of low. You have this opt-in model, and you just kind of provide a thing for them and then give them requirements to do it. They may not be prioritizing that type of thing, right? So what I decided is I wanted to create these requirements, but then I also wanted to do it as a service. So I wanted to help accomplish these tasks with the engineering teams, not just come to them and say, do this, I've given you a tool, what else do you guys want, right? Like, just figure it out. No, what I wanted to do was say, okay, you guys need to do this, and by the way, we're just gonna do all the heavy lifting for you, right? We wanna keep you doing what you're doing, writing the code, and spending as much time on that as you can, and we can help you with the security, right? So I had a few key tenets that I wanted to do when designing this system. I wanted the onboarding to take little to no effort from the engineering teams, and then once they're onboarded, they basically don't have to do anything, right? It's up and running, and they're good to go. So, the security team, what do we get? We get assurance that the thing is happening, right? We also get a standardized, centralized solution, so we know that the requirements are being met because we've vetted that system, and it's not this team uses this code scanner, this team uses that code scanner, and they may or may not have the same coverage, it may not work, right? So we have these assurances. And then the engineering team they just get action items directly into their workflow. So going back to kind of the title of our talk, where we want to be where our engineers are doing their work, we don't want to design this system that's really cool from a security perspective, right? Like, we've designed this really cool thing, and it detects all these vulnerabilities, there's dashboards, there's reports, there's all this data that engineers may or may not care about. If you design a system that no one utilizes and no one logs into, then why did you waste all that time, right? Engineers want to write code. They may be interested in this cool security metrics, they may not, right? It's not their primary function. So anyway, I decided that was a pretty lofty goal, and in order to accomplish this goal, I needed to automate everything because, also it needed to be scalable because at this point it was just me, and I needed to push this out to hundreds of developers, right, and millions of lines of code. So how was I going to do that just by myself? So came up with the idea of building an automation platform because the solution needed to be scalable. So with the automation platform at its core was designed to be scalable. Additionally, I didn't want to build a system to just solve one problem. I wanted a system that could support solving multiple problems. So once again, using the example of static analysis, that was the first thing we kind of onboarded this system was how can I build this to solve that problem, but then leverage this in the future to solve additional problems. So it needed to be able to take inputs from any source, right? It's agnostic of where the stuff comes from, and then it just pushes through the workflow that we've identified. So basically, did that. So this obviously isn't a very technical diagram. I'm happy to get into the technical specifics if people want to talk about that. That's outside of the scope of this talk, but approach me, send me an email, whatnot. I'm happy to talk about how this was all built and whatever level of detail you want. So anyway, this is just to illustrate kind of the workflow and the methodology behind working where your engineers are working, right? So as you can see, you have the engineers happily coding away. They then check their code into some sort of source code repository, in this example, Git. Then at the core of the system is our automation servers, or it's just represented there, but it's a cluster of servers, right? And so then it checks out the code at whatever interval you want, right? On a commit, maybe you want to scan monthly, nightly, weekly, quarterly, whatever you decide, right? That's all handled by this automation system. We then, utilizing the API of our code scanning system, in this case checkmarks, we then scan that code, process the results. Those results get processed by our engineering or our automation server, and then they get pushed to the developers in a couple different ways, right? So they get an email summary that says, oh, your code was scanned last night or whatever. Here's a summary of what was found and if anything, and here's the reports. And it's just kind of an FYI. That could get sent to everyone. It could get sent to nobody. It doesn't really matter because the main part of the system is we input issues directly into our bug tracking system, right? So if Checkmarks finds a vulnerability, then instead of notifying the engineering team and say, hey, our static analysis scanner found a vulnerability, here's a PDF report that you can then decipher, or you can log into Checkmarks directly and figure it out there. No, we just take all the information they need, create a bug automatically, and then put and then it goes directly into their workflows, right? So as far as they know, they're coding, and they don't have to kick off any scans, they don't have to do anything like that. They just get bugs in their Jira queue. They can pull them into sprints, they can do whatever they need to do. This has also given us some other benefits in terms of like efficiencies, right? So I don't know how many people are familiar with like check marks or other code scanning, the way that the way they report vulnerabilities. But say you have 15 instances of cross-site scripting in index.php, which nobody ever has, right? But say you do, right? Check marks will then report 15 different vulnerabilities, right? But that may or may not be how those vulnerabilities are then remediated from an engineering team, right? Like, do they have to go into each individual bug and solve that, or are they just gonna like use some sort of library or class to solve it all, right? So we then take all that and put it into one Jira issue and say, you've got a Jira issue, you got a problem, you got cross-site scripting index.php, here's every single line or instance where it was found. So they'll go and resolve it, they can close one bug, they don't have to close 15 bugs, they don't have to log anything else, and then we just kind of move on, right? So all of that to set up the what I term software composition analysis or third-party library discovery, right? So let's get into that. Now that you have some insight into our processes and system, let's get into this, right? So in September of 2017, roughly, the world learned of that some company had a security breach that leaked a small amount of data, right? This company was using an unpatched vulnerability from a third party, right? That unpatched library had a remote code execution vulnerability. Now, we're all very familiar with this, I'm sure. If not, I'm happy to talk to you afterwards. We can talk about it at depth. But so anyway, what's with this quote, right? Well, you know the old saying, there's no such thing as bad press. Well, in the security world, I kind of argue that there is. This quote comes from this representative, Greg Walden, who was on a member of the Senate subcommittee that was investigating this particular breach with this company, right? And I would submit that being associated with this quote probably is not something that you want for your company. So kind of want to avoid that kind of thing, right? So if this were to happen, without any systems in place to handle this, let's take a look at the response process. So let's say Apache Struts has another vulnerability. We know that won't happen, but let's pretend that it did. Oh, actually it did. The same exact thing happened a couple months ago, so maybe it does happen. But here's the manual way of resolving this, right? So the security team reaches out to engineering team via email, meetings, phone calls, whatever, right? However you engage the engineering teams to get information from them. Then the engineering teams will get back to the security team in some way. Maybe it's the same format. Maybe they say, oh, we've got a wiki page that tracks all that, or it's all in Jira, or whatever the case may be. Or maybe they don't get back to you at all, or maybe there's a long time that it takes. Like this maybe isn't an easy question for them to answer, right? Maybe they just don't know, and they're like, well, it's going to take us some time to figure this out. So you can't dictate a timeline. You say, we need this answer by tomorrow. They could say, it's going to take weeks. We don't know. So you have this, right? And then you get all that stuff back, and then the engineering team or the security team then needs to track that, right? And how do you track that? Do you track it in a wiki page or Jira tickets or email threads that get lost, wiki pages get stale, and so you're doing all of this stuff to kind of solve a one-time problem or a one-time incident, right? So you can't reliably use this stuff if you have to deal with this again, right? You can go to your wiki page and say, oh, that was updated a year ago, so who knows if that's accurate. I know that was in my email somewhere, it's lost, right? So not ideal, but that's kind of the way that you have to do it if you don't have the ability to find this stuff, right? So you see that kind of process and you ask yourself, isn't there a better way? Well, yes, there is. So we take our automation system again, and ta-da, now it supports software composition analysis, right? So because, as I mentioned, we wanted the system to be agnostic of whatever the inputs were, we can utilize that, we can leverage it, and then put another system in place, well, in this case, in parallel, right? I just kind of put this replacing to see, like, you can drop anything in there. As long as it has an API, like, you can use that, and then it can push the results to Jira, you can send emails, you can do a lot from that, right? So you can see we will follow the same exact workflow we did before, right? And in this case, we are actually leveraging the work that we had done previous to this by onboarding everybody and having all these code repos. We can scan the code, right? We already have that. The teams don't need to do anything. We just put a system in place, and then they start seeing results. Like, there's nothing that the engineering teams have to do. And you say, well, that's great. You're scanning code. But as we all know, there's probably some build process that inject binaries during that build, right? Well, we just build a little plugin to do that as well. So we can scan binaries as well as code, right? So we can support all that. But the main thing to take from this is we already have all of this stuff in place. So whether it's static analysis or software composition analysis or dynamic analysis, we've written plugins to upload like pen test results or like CSV files that can then push this stuff out in a standardized format that then we can then track, right? It's all centralized. So the main thing is knowing that we have this automation system in place that can support all this. So we talk about the results of our SCA system, right? Basically, we now have a centralized repository of all of our third-party libraries and where they are, right? So if someone says, I need to know if this vulnerable version of Apache Struts is anywhere in our code, the security team then can just say, yep, it's right here, or no, we don't have it at all. And we know this because we're scanning everything, or we're scanning every binary. We have every line of code going through the system on a weekly basis or on a nightly basis. So we know that, right? We don't have to reach out to all of the engineering teams, and maybe there's false negatives because they say, oh yeah, we don't have that stuff, and lo and behold, maybe they do, right? Not their fault, they just maybe didn't know. So, gives us that centralized repository, which is really, really powerful, really beneficial. Additionally, then we have a significantly reduced response time, right? Like we all went through that process that I showed before. Now, instead of that, we can just go to the team and say, I found Apache Struts, this version, here's all the places I found it, please go patch them, and now you have a response as a matter of hours as opposed to days, weeks, potentially months, right? And then obviously less overhead, right? The engineering teams don't even have to worry about this. We've already done all the heavy lifting, and then we just help them out there. So here we are, we're back in Mordor. Working where our engineers live has obviously been integral in our success, right? It's enabled us to be able to build processes on top of systems, and because of that, we don't have to then roll out some fancy new process or train program management or train engineers every time we want to do a security thing, right? We're already doing things in Jira. We just have to basically bolt it onto our existing system, right? So in the case of the software composition analysis, we already had the scanning in place. We didn't have to go to the engineering teams at PGM and say, oh, by the way, there's this cool new security thing that's really going to be great, but this is all the stuff you have to do to be familiar with it, and this is all the stuff that you have to do to make sure it runs successfully. We just did it all on the back end, and then they started seeing stuff and started fixing things, right? So basically, to conclude, we're off on a journey with our engineers, not against them. So we just want to be consistent, right? And to do that, we have to automate, and then we can help our engineers deliver software that we can all be proud of, and then we have a party. So anyway, that's it.